Okay, students, go over to your practice DCAS test version number 1. Then you'll also be able to use this to do version 2 over spring break or whenever I've assigned it for that particular year. All right, Brian's hockey team is purchasing jerseys. The company charges $250 for a one-time setup fee. When you see a one-time setup fee, you could also see an initial cost. Okay, you could also see the words initial value. Okay, those are all referring to the y-intercept. Okay, that's the y-intercept, which then in our equation, we know from slope-intercept form, that is b. So therefore, 250 is the b. And it says $23 for each. When you see the word for each, that is slope. Dead giveaway, slope. Okay, so keywords you should be looking for when you're reading a word problem. So I better see 23. Change the color. Y equals 23x plus 250. And they could have switched it and not put it in slope intercept form and put it as 250 plus 23x. That's the same thing. There's commutative property of addition, just switched those two terms. And so which one do we see there? 23x plus 250 right there. All right, number 2, which table represents a function? You know, a function for every x there's only one y, and thus no repeat x's. That's when you see a table, it's the first thing you're looking for, no repeat x's. So you're looking for one that, there's repeat x's right there, gone. There's repeat x's gone. There's repeat x's gone. So nice and easy right there. Okay, it should be an easy free point when you see it on the DCAS. All right, number 5 here. Josh graphed the function fx equals that. He then graphed this function on the same coordinate plane, the vertex of the g. Remember, and this is going to be on your tests, you know, a retest. You need a retest. You should always write down opposite and same. I told you this before the test. As a reminder, it's the opposite, and this is next to the x coordinate, so that's the x value. Opposite of -1 is +1, and the same there is -5. Okay, so that's the vertex of the g function, g of x vertex. The f of x vertex, again, opposite, 1, and same, 2. Okay, we can see that they have the same, if I plotted those points, 1, 1, 2, 3, 4, 5, 1, -5, and 1, 2, right there. If you can't visualize it yourself, plot them, and you can see that this one, which is right there, is plus 7 units higher, 7 units above the vertex of, 7 units, the g of x itself. So we're going, the g of x is the opposite direction. G of x is down here, so it's 7 units below f of x. It depends on which order they're referring it to. They want to refer g, they want to compare g of x to f of x. So the g of x is 7 units below the vertex of f of x. Okay, pay attention to the order that they write it. Which expression is equal to that? So that's just distributive property and combining like terms. Should be 3 points. I get 2x squared minus 2. Here I have 3x squared and minus 12x. Notice I just lined them up in like terms. So I have 5x squared minus 12x minus 2. Right there. Should be 3 points. Multiplication. All right, number 4. Solve for x. You can always remember I have a proportion. I can always cross multiply if I wanted to. Don't forget when you have more than one term in the numerator denominator, you put parentheses around it so that 3 would need to get distributed. You can always do that. Or I can look at the shortcut here. 3 times what is 15? Times 5. So that means this has to be times 5. So what is 4 times 5? 20. So that has to equal 20. So what plus 10 equals 20? 10 does. Okay, but if you can't handle that, just cross multiply. All right, number 37. Alyssa spent $35 to purchase 12 chickens, 2 different types, American, so American chicken plus Delaware chicken, total of 12 chickens. Chickens go together, okay? Our types of chickens and our total chickens go together, then our costs all go in one equation. Just remember that. So 370 for the American, 375 for the American, and 250 for the Delaware. You line them up like terms for a total of $35. So I want to eliminate one or the other. I got to get the opposite. So if I want to eliminate, for example, the D, I'd be multiplying this by negative 2.5 for negative 250. So it wipes out the D's. So then I have $3.75 minus 250 is $1.25 for the A. And I have 12 times negative 2.5 or negative $2.50. That's 24 plus 6 is 30. So negative 30, when I multiply that times that, negative 30 plus 35 is 5. Divide by 1.25 on both sides, and you get 4. So A is 4, and then I know A plus D is 12, so D has to be 8. Okay? Now, the reason, again, we want to work this out with systems is because it might be on a DCAS, just set up the system, that system right there, that would solve this, and you don't even solve it. They want to set, you can set up a system, so they don't want to see a guess and check method. All right, 6. Survey was given to 12 grade students, okay, and so we're going to say the nearest percent, what percent of the boys chose Niagara Falls. Notice it doesn't care about the girls, we only want the boys. Here's all the boys. So I got to total that up for the total. 121.30, 233. Okay, for the total. And it says how many of those chose Niagara? 56. 56 of that 233, which is approximately 1/4, a little less than 1/4. Okay, because that would be 224. 224 would be 1/4 exactly, so it's a little less than 0.25. So we have 0.24 approximately, and then you change that to a percent. Remember, 2 places to the right for percent, so 24%. Okay, we should recognize this as an exponential function. So, but I'm just looking for it. Oh, there it is right there, exponential. We know linear, be straight. Okay, no curve at all. Line is linear. Square root function, if you forgot that, square root function looks like that. Okay, so that's a square root function. And then the absolute value function, remember, is always a V, up or down, for example. So you need to know those, okay, in case you see those on there. They just ask you, notice this is just a vocab question. What's the name of the function? So you have to know the different shapes. This, remember, whenever I see a binomial, I should be thinking difference of squares or difference of perfect squares. I don't care which one you call it. Okay, the common way nowadays is difference of squares. They dropped off the perfect, but now first thing I would do would look to see factor out the GCF first, if there was one. Don't forget that. But since there is no GCF here, now I go right to the difference of squares, which means I just take the square root of each. 4x is the square root of 16x squared, and the square root of 81 is 9, and 1 is plus and 1's minus. Boom, right there. Okay, anytime you have a binomial, factor out the GCF first if there is one, and then look for a difference of squares. Okay, number 9, the owner of landscaping business wants to know how much time on average his workers spend mowing one lawn. Which is the most appropriate rate? Which would be the most appropriate rate to calculate the answer to his question? Wants to know how much time on average his workers spend mowing one lawn. Okay, so we're looking at hours per lawn then, right? Because you want time in there and lawn, keywords. Okay, a ball is thrown in. Okay, you're guaranteed to have this on the DCAS. Guaranteed. It'll just be different numbers. Okay, it'll just be like this. All you gotta do is look at the equation. Okay, it's quadratic. We just got done doing quadratics. Okay, how do I find the, and this opens down, see that negative 16t squared? That's really narrow, right? That's the shape of the graph, and it opens down. So it looks something like this. Okay, but narrow. Now notice this, how many seconds after the ball is thrown does the, how many seconds after the ball is thrown will the ball hit the ground? Okay, so it's gonna hit the ground when the height is 0, right? Height's 0. Okay, this is the height, h of t. This is time for seconds. Okay, t. So we want to set it equal to 0. Okay, if they ask for when does it reach its maximum height right there is at the vertex. Then they'd be asking to find the vertex. So you're going to get either a question that asks you to find the maximum height, which means I got to solve, do the x equals negative b over 2a, which you need to know for your axis of symmetry, which is also the x coordinate of the vertex. Okay, that will give me the time that it reaches its maximum height. And then the y coordinate, after I get that answer, plug it into the equation, get the height, and that's the maximum height itself. So you're going to have either that question or you have this one where it asks where it hits the ground. So where does it hit the ground? Right there. So we set that's the height equal to 0. Now we're solving this quadratic. Okay. So I have 0 there. Now I can see, you may not be able to see, but negative 16 goes into each of these. So I have 0. I'm dividing, that's a negative 16, so that's still 0. So now I have t squared minus 4t minus 5. Okay. So remember, when I'm solving quadratics, if it's not a calculator problem, I want to see about, if it's a solving, I want to divide by the GCF. Okay. If it was factored, I can't divide by the GCF, I have to factor out the GCF. But when I can solve it, I can divide by it, get down to that small number, and now you should be able to simply factor that. T minus 5 and t plus 1. So that would be at negative 1 second, which means it would be hitting right over there, and the other one's at 5 seconds. That right there would be the 5, because that's going to give me t equals 5. So 5 seconds is when it's going to hit the ground right there. Okay, guaranteed to have this on the DCAS, either in this format when it hits the ground, okay, or now if it didn't factor like it did right here, remember you can always use quadratic formula. The quadratic formula, don't forget, is given to you as on your formula sheet on the DCAS, so you don't have to have it memorized, even though you should for going into Algebra 2, but if you don't, it's going to be given to you on the formula sheet. Okay, and you can just plug in your A, remember, A, B, and C in the quadratic formula. Okay, and that will give you the time. Okay, so maybe it's going to come out to something seconds, point something seconds. Okay, and you can do that. So if you can't factor, you can always plug into the quadratic formula. If you forget how to factor it, you use a quadratic formula. Quadratic formula always works. Factoring sometimes works, it does here, sometimes it doesn't work, but quadratic formula always works. So when in doubt, revert back to that quadratic formula. Plug it in. Okay. Which equation is equivalent to this? Okay. Now, if you don't know, you could sit there and multiply everything out, multiply that whole thing out and subtract 162 and see if you get that. But what's smarter, okay, we talked about completing the square, okay? I'd have x squared plus 24x plus blank, okay? And then I have this minus 18, okay? Now, remember, complete the square. This is that c. We just went over in the last class here. That's a c. So how do I get that? It's always 1/2 of b squared. Okay? So half of b is 12. 12 squared is 144. Now notice that 144 in there. I added it. It's 1 times 144 is 144. So since I'm keeping it on the same side, I need to subtract off 144. Okay, now 144 minus 144 is 0. I haven't changed the problem at all. So notice now I get y equals x plus 12 squared. Because remember, this is always going to be, if you do your half of b right with that sign, Okay, it's going to always be right there, and negative 18 and negative 144 is negative 162. Okay, so where do we have that? Number 1. Okay, so that's using completing the square. Now let's say you somehow forgot that. Remember, I can get the x coordinate of the vertex by taking negative x equals negative b over 2a. You never want to forget this, negative b over 2a. So that'll be negative 24 over 2 times 1 is 2, which now gives me negative 12 for the x coordinate. Remember, if it's negative 12, I need it to be the opposite when I put it in the equation into vertex form. Remember, that's called vertex form right here. All these down here, vertex form. Okay, you're just getting tested on this just recently here. So I got to do the opposite for the x coordinate. And now, so it's going to be that one. So it wipes out the 2 negatives over here. Now I could plug the negative 12 into this equation, get the y coordinate, and it's going to be negative 162. Okay, so that's another way. If you forget about completing the square, you can always use x equals negative b over 2a. Okay. All right, next, 12. This is when it's expressed in standard form. Remember, standard form, ax squared plus bx plus c equals 0, or equals the y coordinate, or f of x. Okay, which statement is true about the resulting polynomial? Well, if I multiply that times that times that, that's going to give me the leading coefficient, and that's going to give me 2x cubed. Okay. The leading coefficient is 2, right there. Okay. The degree is 2. No, it's not. The degree is 3. The number of terms is 2. No. You're going to have 3. The constant term is 2. There is no constant term in here. Okay, because if I multiply these two, you'd have a constant, but then I'm going to distribute the x through there, so it'll end up with an x at the end. No constant at all. Okay, so I didn't even have to multiply that whole thing out. Okay, the population of a city can be modeled by this. Okay, this is what we're going to get into when we come back from spring break, for this year's class. Okay, skip this unit. Which function is approximately equal to the p of t? Well, you need to know your exponent rules. When I have a power to power, I can move that inside of there. So 3810 times 1.005 to the 7th to the t. And notice that's what they've done. And so you just put 1.005 to the 7th on your calculator, and that's going to give you one of these numbers. Notice everything else, well, it wouldn't be these two because it's the wrong one. This is, so on here, just that's called the initial value. That's your y-intercept. Okay, remember how we had IV on those initial value? Okay, that's always your y-intercept. That initial value is another word for y-intercept. That doesn't change. Okay, so you're down to these two. And to the power of 5 to the 7th is they did 5 times 7 to see if you blew it, didn't know what 5 to the 7th was. Okay, so I didn't even need a calculator here. I can come up with that right there alone. Okay, because I've already wiped those two out because they have the wrong leading initial value. And you don't do 5 times 7, 5 to the 7th. Remember, that means 5 times 5 times 5, 7 times. That's a lot higher than 35. 1, 2, 3, 4, 5, 6, 7. That's a lot higher than 5 times 7 what they have there for that 35. Okay, so use some common sense like that. You can come up with that answer without even using a calculator. Okay, here's your f of x, is that function next to it, and there's your g of x. So we have a polynomial, the curved one is a polynomial, okay, and then we have a line right there. It says, for which value of x is the f of x not equal to the g of x? Well, where are they equal? They're equal there, there, and there. What are those x values? What's the x value right there? -2, -1, -2 they're equal, -1 they're equal, and 2 they're equal. So it's the one that's not that, which is then 3. The range, several people in this, that's the high number minus the low number. You need to remember that. So 8 minus 1, 7. All right, which expression is not equivalent? Okay, so this comes down to your factoring, and this is why you need to show all your work, because 3 of these are the same. Now remember, I factor out the GCF first, so I have x squared plus 5x plus 6, okay? If I'm doing it right. Then I should be able to easily factor that into x plus 2 and x plus 3. Nice, simple algebra 1 factoring. So that's the completed form right there, which you see right there, don't you? Okay. Now, so that's true, because that's obviously our answer, the most factored complete form. So now 3 of these others have to be equal to that. So if I look right here, notice they forgot to factor out the GCF of 2. So if I take that 2 out now, what am I left with? X plus 2. Isn't that the exact same thing now as that right there? So that's true. Okay, now here, they forgot to factor out the 2. And I'd be left with x plus 3, oops, times x plus 2. And that's the same thing I have right there. So that's true. Okay, so this is the one that's false. Now you can easily see this. If you remember my method, I draw my 2 smiley faces. I did this because several of you missed this on this. I drew the 2 smiley faces. Remember, that's 8x down here, and that's 3x there. And what's 8x plus 3x? That's 11x. And what does that say? It is supposed to be 10x. Okay, so that's another way you could do it. Okay, I could just multiply all these out. And boom, I get 2x squared, yes. 8x plus 3x is 11x. Nope, false. I could have just done that and multiplied it out. So just don't forget you can do it that way as well. All right, the quadratic functions are given below. 2 different functions. Q of x right here, so this is obviously r of x, as you see right there. Which function has the smallest minimum value? Remember, that's the y coordinate. Whenever they ask minimum value, y coordinate, not the x. Okay, so right here we can see that is, and it's always going to occur at the vertex, right? The minimum value is at the vertex, so it's negative. That's -2, -16 for that vertex opening up. What's the vertex here? Remember, I get the x coordinate from -b over 2a. You can't forget this. So I have -2 over 2, which then gives me -1 for the x coordinate. Now I plug that -1 into there to get the y coordinate. So y equals -1 squared, which is 1, plus 2 times -1, which is -2. So 1 minus 2 is -1, minus 8 is -9. So that minimum value is -9. Well, obviously -16 is lower, the r of x, and the value is -16. Several of you missed that. You're going to have one like that on the DCAS. They're going to always ask about the vertex, minimum maximum value. Child's playing outside. Graph below shows child's distance, d of t, in yards from home. Okay, so as he's walking, he's coming closer to home. This way he's going further away from home. Okay, this he's going away and then coming. In this way he's staying the exact same distance away. Okay, so you got to know how to read that. Which interval represents him constantly moving closer to home? See, that distance is getting shorter from 10 yards away down to 4. That's constantly getting shorter. That's from 0 to 2 is your interval. Okay, you'll have that. It's just reading graphs. Okay, and knowing your, oops, let's see, where is that? Right there. Okay, so next one right here. Okay, now here we have our recursive formula. Remember, in recursive formula, they have to give you a sub 1, always. So a sub 2 would equal 3 plus 2 times, I plug in a 2 there, I get a sub 1 squared. And I know what a sub 1 is, 6. So I just plug it into there. I have 3 plus 2 times 6 squared. Now you have to remember PEMDAS, order of operations. A lot of you blow this. I know exponents come first. In PEMDAS, we're going down. Boom. 6 squared is 36, times 2 is 72, plus 3 is 75. There's your answer. All right, 20. Let the length of the rectangular patio is 7 feet more than its width. So you draw a rectangle. Okay, notice they're using W for width. So there's my width. Okay, 4 right angles is the definition of a rectangle. Opposite sides congruent. Okay, those hash marks mean they're congruent. That's geometry. We can learn some geometry right now. So that's what a rectangle looks like in geometry. Or you could have just had 4 right angles. That's also the definition. All right, so it says the length, which would be right there. Okay, the long one is 7 feet more than the width. So it's W plus 7. So now we plug in W plus 7 right there. Okay, and now it says the area. What's the area? Well, you should know that area is length times width, or base times the height, same thing. So we just multiply those two together. So W times W plus 7. That equals W squared plus 7W. So they might give it to you in that form or that answer. They're the same thing. Which one do we see here? Right there. Okay, notice they used A for W and A for area and W for width. All right, the dolphin jumps out of the water and then back into the water. His jump could be graphed. Okay, parabola. Jumps out, comes back in, parabola. The domain, which are all these x values, is best represented by what? Are these x values only integers? No, it's every second, right? So positive real numbers. Can't say real because I would include negatives. We're not talking about him underneath the water. We're talking above the water, so it's positive. All right, which system of linear equations has the same solution as the one shown below? Well, I can easily multiply this one by -1, so I get my opposite sign, so x's cancel out. So I get 4y plus 1y is 5y, and I get 10 plus 5 is 15. So y is 3. Plug it back in, 3 plus what is 5? X is 2. Real quick to solve that. You should all solve that real quick. Now I can just plug those in and see which one has the same. So if I plug in 2 there, 5 times 2 is 10, that's true. Is 2 plus 3, 5? Yes. Okay, if I check this one, -5 times 3 is not -5. That's false right there. Okay, if I do this one, 2 minus 12 is -10, yes. -5 times 3 is -15, no, false. If I check this one, -3 times x, -3 times 2, is that -30? No, it's not, false. Okay. Which represents the range. You need to remember from function, our function range is the y values, domain is the x. You need to have this down. So here I have a quadratic that opens up, right? I know the shape is 2x squared. Remember, that's always my ax squared is my shape. So it's going to be narrower than my parent function of y equals x squared. Okay, the range obviously is going to be from the minimum value of that y right there of the vertex all the way up to infinity. Okay, so now they all have up to infinity there with the parentheses around like you're supposed to. So now the question is finding that vertex is what they're really looking for, then the y coordinate of the vertex. So remember, I can do the x coordinate, -b over 2a. Remember, -b over 2a. See how many times we use this. -b is 2 over 2a is 4. So x is 1/2. So remember, that's the x coordinate. So they went and put that in here. Okay, right here to see if you choose the x coordinate. As when I talk about x's, we're talking about the y's because we're talking about range. So those two are gone. Okay, now so we're going to stick that 0.5 into both those x's and get the y coordinate. Okay, so notice now I don't even have to plug it in because they both give me the same value of -4.5. So the question is, remember, parentheses does not include 4.5 and brackets does include it. And of course, this is actual point on it, so it does include it. So there's my answer, -4.5 to infinity. Okay, common ratio of geometric sequence. I got to remember geometric sequence means to multiply from one term to the next. Multiply or divide, because division really is multiplication by the reciprocal. Okay, so you can say multiply or divide from one term to the next. Well, it says the first term is 5. I don't know what the second term is, and the third term is 245. So 5 times some number gives me this one, times that same number gives me that one. Well, if I do 5 times 49, let's just say 5 times 50, it's already 250. That put 250 right there times 5 way over. And these are even higher numbers. So just from process elimination right there, it's 7. So if I did 5 times 7, that's 35, and 35 times 7 is 245 right there. You can easily set that up. Okay. All right, determine the g of -2. Remember that these are always, when I have inside the parentheses, those are always the x values when it's inside the parentheses. So plug that in for the x value and just calculate it. That's it. Basic math now, PEMDAS. Remember I put parentheses around it when I substitute in. Don't forget your parentheses. So I got to do PEMDAS. I got to do exponents first. Got to remember order of operations, PEMDAS. So this exponent comes first. That's 4. Then I do multiplication. 4 times -4 is -16. And -3 times -2 is +6, and then +2. So I have -16 plus 8 is -8. There's that answer. Guaranteed to have something like that. Okay, on the DCAS. All right, let's erase that so we see. A student is in the process of solving the equation. The original equation and the first step are shown below. Okay, so here's the original and the first step shown below. So what you have to do is what happened between the first and second step? Nothing changed on the left side, so I'm looking at the right. Okay, for whatever reason, they didn't combine like terms like they should have. They just rearranged it. So when you rearrange your positives and negatives like that, that's just commutative property of addition. Commutative property of addition. Okay, they just switch that order right there. If it had parentheses involved in it and they switched where the parentheses were located, then that would be associative property of addition. It's of addition because you're adding, you're not multiplying. Okay, graph this line. Well, we know we solve for y and put it in the slope-intercept form. Y equals mx plus b. So -1 for my y-intercept, down 3, 1, 2, 3, and right 2. Okay, remember I can write it as -3/2, or I can change and put the negative in the denominator, make it up 3 and left 2. 1, 2, 3, left 2. Notice those are right in line with each other. And there would be my line. Okay. All right, next one. The linear equation contains the point 2 comma k. State the value of k. The formula, wait a sec here. Do I have something else I'm missing? Oh, okay, so this goes along with this equation right here. So stick in 2 for the x, right there. Okay, plug it in. So I now have y equals -3/2, and then 2, which can be written as 2/1, okay, -1. And the k value, that's just your y value right there. So all I'm doing is this calculation. The 2's cancel. I get -3 minus 1, so -4. K is -4 then. Okay. All right, 28. You have this formula right here. Change in velocity over a period of time. Solve the formula for the final velocity v of f. There's your v of f. Or I can write it as in proportion and cross multiply. So I'd have v of f minus v of I equals at. I cross multiply. Remember, I'm solving for v of f. So the last thing I have to do is add that v sub 1 across. So the v sub f equals at plus v sub 1. There's my answer right there. Okay, is the product of two irrational numbers always rational? Remember, we just got done talking about rational, irrational. Irrational is anything that's a square root that's not a perfect square. So square root of 7 is the product. You gotta know that means multiplication. If I multiply square root of 7 times square root of 2, that just gives me square root of 14. Isn't that still irrational? That is. It says, is it always irrational? No, we know that because we've just been doing this. What's the square root of 7 times the square root of 7? 7. Okay, that's a rational number. We had to rationalize the denominator. We multiply by that same rational irrational number to make it rational. Okay, so that would be your just fine. You'd say square root of 7 and square root of 7 equals 7, which is a rational number. So the answer is no. All right, how to solve this? Just add the 42 across. I have 6x squared equals 42. Reverse PEMDAS, divide by 6. X squared equals 7. Remember, that squared tells me there's two answers. How do I get rid of that squared? I do the square root of both sides. I have to add that plus or minus in there. Okay, so x equals plus or minus the square root of 7. Always two answers with quadratics. Even if it's the same number twice, it's still two answers. All right, here we have a piecewise function that almost every one of you missed on your test. So pay attention. Now, hopefully, more than likely, this will be a multiple choice on the DCAS. And it'll have four, form graphed A, B, C, D, and you pick out what it is. Okay, instead of you actually having to write it yourself, it's probably going to be a multiple choice. Okay, remember, all you do is plug in 0 for that. 0, 2 times 0 is 0, minus 3 is -3. Since that doesn't have the equal sign, it's going to be an open circle there. 0, -3, open circle. Okay, now I just use that slope. It's a line. Slope is 2. 2 over 1, up 2, right 1, or -2 over -1, down 2, I meant, and left 1. Okay, and we want it for it being less than 0. So over here, so it needs to be going off that. So we need to go left 2, or down 2, left 1, down 2, left 1. Okay, there's that piece right there. Can't go to the right of 0 or even a 0. Okay, here, notice we have a parabola from 0 to 5. Okay, we just got into parabolas. Okay, if I want to use completeness square, I could use my negative b over 2a. Okay, and get that. I could also use my completeness square that you just learned here recently. So that'd be x squared minus 4x plus that blank, which is the c. And then I have minus 5. Okay, and it's going to be minus since I'm at it, and it's half of b squared, which is then -2 squared, which is 4. Since I added 4, I need to subtract 4 since I'm on the same side of the equal sign. So notice then that becomes x minus 2 squared minus 9. So at 2, it'd be at minus 9 right there. We know we go right 1, up 1, left 1, up 1, left 2, up 4. 1, 2, 3, 1, 2, 3, 4. And right 2, up 4. 1, 2, 3, 4. Okay, so it's going to go like this, and it's going to stop at 5. Notice we're stopping at 5. It's going to come up a little more. If I want to actually get 5's value, I just plug 5 into 25 minus 20 is 5 minus 5 is 0. So it comes already up to 0 right there and stops. It only goes to 5, doesn't keep going. Okay, so that would be the shape of that piecewise function right there. All right, next, on the same set of axes, graph the system of inequalities. Notice both of them, well actually one's in standard form and one's not. You can easily move it to slope-intercept form by adding the 5 across. Okay, remember the easiest points to plot in standard form, which you have to know how to do because they're going to ask you to graph a line using the x and y intercepts. X-intercept, easier to remember which one is set equal to 0 because I want to solve for x. So y has to be 0. So therefore x is 4. For the y-intercept, we set x equal to 0. X is 0, so y is 8. X is 0, y is 8. Plot them, 4, 0, and 0, 8. It's going to be a solid line because it has an equal sign. Okay, we'll do the shading last. Okay, second one, we have y equals, or y is less than 3x plus 5. You got your slope right there, 3 over 1. Y-intercept, 5. So I can go up 3, 1, 2, 3, and right 1, or I can go down 3, left 1, 1, 2, 3, left 1. That one's dashed because there's no equal sign. Okay, so that's a dashed one. Let me change the color so it stands out more. Okay, and we'll make our shaded part green. Okay, so the first one, if I leave it in standard form, I could have just moved that across, made it minus 2x plus 8. Okay, and then they're both in slope-intercept form. Okay, so for those of you who want to do that, If it's not asking you to use the X and Y intercepts, you can do that. And since it's positive, Y, the coefficient is positive, I keep that same sign. So it's going to be greater. Okay. So this was equation 1 is greater than. So it's either here or here. Okay. And then on this one, Y is less than. So it's less than on this one. Here and here are below that line. So where do I have 2 dots? Right here. So this should be my solution right there. Okay, that's what it should look like. All right, determine if the 0.18 is in the solution set. Okay, so now I take that 1/8 is 1/8. 1, 2, 3, 4, 5, 6, 7, 8. 1/8 is right there. Is that in the solution set? The answer is no, because this is a dashed line. It's right on that dashed line. Dashed lines don't count. Points don't count. Do not count if on a dashed line. So it's not in the region. Okay, so there's that one. So notice if they're going to ask you that, it's probably going to be on a dashed line. So more than likely the answer is no. They want to see if you know that. Remember that for the DCAS. All right. On the day Alexander was born, his father invested $5,000 into an account. So that's the initial value, $5,000, with a 1.2% annual growth rate. Whenever you see this in percents, it's going to be an exponential function. T in years, that's my exponent. So it's 1%, 1.2% growth. Go 2 places to the left. So 0.012. We are adding that to 100%, which is 1.00. That's 100% is 1. So then I get 1.012 to the T is my equation. Okay. Now it says determines the nearest dollar. So you round the nearest dollar, how much more time the investment will be worth when Alexander turns 32 than he was when he was 17. So that means I got to plug in the answer for 17, get that answer, plug in T for 17, get that answer, plug in T for 32. So this is going to be a calculator problem. Get that answer and then subtract the 2 and round to the nearest whole number, nearest dollar. All right. Stephen collected data here. Data includes a hotel's distance from Times Square, Manhattan, and the cost of the room one weekend in August. A table containing these data appear below. Distance from Times Square and the cost of the room. Obviously, when it's right at Times Square, it's real expensive. As you get further away, it gets cheaper. Write a linear regression equation. This is plugging into your calculator. Okay, so graphing calculator. Start. Okay, calculator's right there in the middle. Hit stat. Remember, we always put it in stat. Enter. L1 are my x coordinates. Okay, so I need to go back. X coordinates 0, 0, 1, 1, 3, 4, 7. Let's see, I can remember that so far. 0, 0, 1, 1, 3, 4, 7. Okay, and what were the last couple? 11, 14, 19. 11, 14, 19. Okay, now I put the y coordinates in the L2. 293, 263, 244. 293, 263, 244. What's next? 224, 185, 170. What's next? 219, 153, 136. Make sure it's 136. Yes, and then lastly 111. Okay, and I can see they're all matched up, so I didn't make any errors. Remember, then I hit Stat, Calc, over to Calc, down to number 4, linear regression, because I even told you to be linear. Our list is in L1 and L2, so I just enter, enter, enter right on through, and there's my equation. So go back and read the question. Right, linear regression, round the values to the nearest hundredth. So we have negative 7.76. Y equals negative 7.76x. And then what was the y? 246.34. Okay, so there's the equation. And now it says state the correlation coefficients. Okay, so now remember I didn't have the correlation coefficient on. So I need to now go and turn it on. Remember it's second 0. Diagnostic on. Remember it's under D. Diagnostic on. Hit the D in the green. Go to diagnostic on. Enter, enter. So it says done. Now go back to stat calc number 4. Enter, 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 enter all the way. And there's my correlation coefficient R. Negative 0.88. Well, it's the nearest hundredth. Negative 0.88 is the correlation coefficient. Okay. And there's your answer. You're guaranteed to have one of those on DCAS. Memorize your steps. All right, that was it. We got through that right there, 46 minutes. You can use any of those that you need to. You should watch this video and then so you're soaking it all in. That's helpful for review. So that less having a review in class. So we've done a lot of review right there. I'll make it quicker. It'll be fresh in your head over spring break. So when I bring any of these up potentially in class, you'll be able to recall that. And then by the end of the week, be able to recall it as well for your test, the DCAS.